In this video, we're going to learn how to find probabilities for a normal distribution using standard normal probabilities table, or it's also called Z-table, and the TI-84 calculator. So first, we're going to start by using the table. Now, in this example, it says that IQ scores have a normal distribution with the mean 100 points and standard deviation 15. If a person is selected at random, what is the probability that the person's IQ is, and the first part is less than 112 points? Well, let's make some notes first. So we know that mean is 100, and for the normal distribution, it's right at the middle, 100. And we're interested to find probability that the randomly selected person would have IQ that's less than 112. I'm going to label or show 112 on this picture. So if 100 is here, 112 is somewhere to the right. It's really not to scale, but I know it's going to be to the right. Next, since we're interested to know the probability that person's IQ is less than 112, I will highlight area under the normal curve to the left of 112. So that should be this area. Now, the reason I am highlighting the area on the normal curve to the left of 112 is because the area under the normal curve represents probability. Now, how do we find this? Well, our first goal is to find area, and then once we find it, then we're going to interpret it as the probability. So what's going to be the area? Well, to find this area using the Z-table, here it is. I need to know Z-score, right? Because like all those areas under the normal curve, it's shaded right here. These are all those numbers. But to get access to those numbers or to find the right number in this table, I need to know the corresponding Z-score. So in other words, I need to find the corresponding Z-score for this value, 112. So step 1 is to find Z-score. Let me remind you that to find the Z-score, we have to take the data value, 112, subtract mean. So what is the mean? It's 100. And divide by the standard deviation. So that's 15. So I'm going to make notes here. 100 is the mean. 15 is the standard deviation. Standard deviation. And that's 112 is the given value. Okay, I'm going to calculate that. Be careful to first calculate the numerator and then divide by the denominator. So I got 0.8. I didn't have to round. That's exactly what I got, 0.8. Now, when we find Z-scores and plan to use them in the Z-table, we would want to have 2 decimal places. So round 2 decimal places. Well, no rounding happened here, but if I want to have 2 decimal places, I will just write another 0 at the end. So once we find the corresponding Z-score, next, in the step 2, we're going to look at the table. So see the table. Now, that Z-table shows areas to the left of the given Z-score, and that's exactly what we need, right? The corresponding Z-score is 0.80 for this value, and we need area to the left. So it's perfect. It means that we will get answer right away. Now, how do we find the Z-score 0.80? So first of all, it's a positive Z-score. I need to be on the positive side of my table. There are 2 sides. Z right here, see how these are positive values? That's the positive Z values, and on the back side I have negative Z values, Z scores. So I'm going back to the positive side, and the first column represents 1 digit before decimal point and 1 digit after decimal point. So that's the first column. The first row indicates the second digit after the decimal point. So in my case, the first 2 digits, it's 0.2. 0.8, right? So technically I have 0 over here. So it's 0.8. So in the first column, I need to find 0.8. That's the first column. 0.8 right here. And next, I have to check the second digit of our decimal point. Remember, it was 0. So that means that I have to stay in the first column. So that's 0 I have. So 0.80. And where this row and the first column intersect, which is over here, right? That's going to be the area, 0.7881. Area is 0.7881. And once we find area, we can now interpret that as the probability. I can write my answer this way. I can say probability that IQ is less than 112 is 0.7881, which is approximately 79%, right? If I move decimal point 2 places, 79% and round up. So that means that the probability that a randomly selected person is going to have IQ of 100, of less than 100 points is 79% chance. Well, let's try that with question. Let's actually skip B and let's go to C, and then we'll come back to B. So in this question, we need to find probability that the randomly selected person's IQ is greater than 130. So I will label that on my normal curve. So first of all, mean is 100 is right in the middle, and then 130 is somewhere to the right. Let's say it's over here. Now, because it says greater, I'm going to highlight area on the normal curve that's to the right of 130. So that's the area. And once I find this area, I will be able to answer the question. So I need to know area. Area equals. I will be able to answer this question because area is going to be interpreted as probability. How do we find this area? Well, we're going to start doing same steps. So in step 1, since for now we're only using the table, we need to know corresponding z-score. Z-score that corresponds to 130. So, and by the way, remember that z-score is how many standard deviations away from the mean that value is. So let's see how far it is. 130 minus 100, which is the mean, and divided by the standard deviation, which is 15. This time I got exactly 2. Oh, that's right. What? That's 30 divided by 15. Yeah, I didn't even need to use calculator. So that's 2. Z-score is 2. Now, then step 2 is to check the table or see the table. Now, there are a couple important things to note. So first of all, once again, when we use z-scores, we want to have 2 digits after the decimal point. So I'm going to put decimal point and add 2 more digits. So the first 2 and 0, 2.0, I will search in the first column, and then the second decimal place should be found in the top row. That's one thing. So in other words, so 2.0 is in the first column. Here it is, 2.0, and I have another 0 for that, so it means that I will be again in the first column. So the row is 2.0 in the first column, so here's the number. But what is that number? So every time I have to remind myself that all those numbers, and actually the table reminds me of this, all those numbers represent areas. See how it's shaded or highlighted to the left of Z? So all those areas, and it says here, table entry for Z is the area under the standard normal curve to the left of Z. So this is the area, the one I found, 2.00 right here, 0.9772. That's the area to the left of the z-score. So where is it going to be on my picture? Well, it's going to be right here, right? This is the area to the left. It's what is it again? 9772. That's the area to the left. But that's not the one I need, right? I need area to the right. Well, but knowing area to the left, I can easily find area to the right because I know that the total area under the normal curve is 1. So if I subtract or take away this area that's in white in my picture, then I will obtain the area I need right here. So here we have step 3, right? Another step we have to do. We don't have the final answer yet. So to obtain the final answer, in other words, to find probability that IQ is greater than 130, we have to take 1 and subtract 0.9772. And then the answer is 0.0228, or about 2%, right? So the chance that probability that person's IQ is more than 130 points is only about 2%. So this is a very high IQ score. But yeah, that's the answer. And that was the area to the right of the given value right here. Now let's go back to question B and see how we find area for question B. So here we want to find probability that the randomly selected person's IQ is between 80 points and 110 points. So on the picture it's going to look like this. So 100 is the mean, it's right in the middle. Then 80 is to the left of 100, and then 110 is to the right. And I want to find probability that person's IQ is between 80 and 110. Well, that probability will correspond to the area on the normal curve between those two numbers. But how do we find this area in between those two values? Well, of course, we'll first need to find z-scores because to use the table, we need z-scores anyway. So here we have to do it twice. We're going to find z-score for 80. We're going to find z-score for 110. Well, let's actually start with that. So in step 1, we're going to find z-score for 80. So z equals 80 minus 100 over 15. That's negative 1.33. Then z-score for 110 is 110 minus 100 over 15, and that's 0.67. Make sure you check those two numbers on your calculator. And by the way, notice how we obtained negative z-score. Why is it negative? Well, because the corresponding data value, which is 80, is below the mean. So for all values that are below the mean, corresponding z-scores will be negative. So this is how many standard deviations this number is away from the mean or below the mean. Okay, so what are we going to find when we look these numbers up in the table? Well, we're going to find areas to the left of those z-scores, areas on the normal curve to the left of each z-score. And let's see how we're going to use it, how it's going to be helpful. Well, once we find area to the left of the z-score negative 1.33, it's going to be area to the left of 80, right? And that's not quite what we need. We don't really need this piece, right? But now when we look up the area that corresponds to this z-score 0.67, we're going to find area to the left, area under the normal curve to the left of 110. And that's everything to the left, which is more than we need. But now think this way. If we find area to the left of 110, all of that, and then take away this piece, take away this area, because we already said we will be able to find it, right? What are we going to be left with? Well, we're going to be left with actually this part in the middle, right? So once again, everything to the left of 110, the entire area, and then we subtract this area of this region, and we will be left with the area that we need. And that's going to be the way to calculate probability or area when you're given an interval like that. Okay, so let's see what's the corresponding area for negative 1.33. So I have to turn my table to the negative side. That's where I have negative z-score, so negative 1.33. So first I will find negative 1.3. Those are the first two digits right here. Okay, so here it is, negative 1.3. But I need another 3 over here, right? So that's where I'll use this first row right here. That's the last 3, the second 3, or the second digit after the decimal point. So I have to stay in this column. And where's the right row? Okay, right here, right? So negative 1.3 and 3 for the second decimal place where they intersect, that row and that column. I get 0.0918, 0.0198. So that means that what I just highlighted in red, this area is 0.0918. Now, as we look up corresponding area for 0.67, which is 0.67. So first I find 0.6 right here, 0.6, and then 7 is right here, right? So the corresponding area is 0.7486. 0.7486. I'll use like green color. So it's all that. So it's more than we need. So what I highlighting in green here, that area is 0.7486. Okay, and now once again, to find area that we already highlighted and we need to interpret probability, we will subtract the larger area, which is green on my picture, and I subtract the smaller area, which is red on my picture. So to find probability that IQ is between 80 and I'll just use the double inequality, and 110, I have to take 0.7486 and subtract 0.0918, and the difference is 0.6568. In other words, about 66%, right? So it's a 66% chance that a randomly selected person is going to have IQ somewhere between 80 and 110 points. So this is how you find probability for the normal distribution by hand using the z-table or using the standard normal probabilities table. But it's actually much quicker on the calculator. And let me show you the steps. So on the calculator, you need to access list of all the distributions. To do that, you press second, then you press vars above, see how it says dist for distributions. And normal distribution is actually right there. Well, there are two functions, but the one that we'll need to use is going to be the second one. So for all those examples, questions, we're going to be using the second one, normal CDF. Let's see what it's going to ask. Okay, so if you have TI-84 plus, it's gonna give you this kind of list that you have to fill out, and based on that, it's gonna calculate the probability. So what is it asking? It's asking for lower boundary and the upper boundary of the region for which you need to find the area. So if we try this for question B, the one we just did, then for the region that for which I have to find the area and interpret it as probability is bounded by numbers 80 and 110, right? So the lower boundary, the one that's on the left, is 80, so I'm going to enter 80, and the upper is 110. Then you should recognize the next two, right? So it's mu, which stands for population mean. If you work with a sample, it would be the same place where you put sample mean, since the process is not going to really change. So in our case, mean is 100. And then sigma, right? To recognize sigma, it's the standard deviation. So standard deviation is 15. And that's all you need to provide to your calculator. Now, I'm going to press enter and we'll compare that, check the answer. But real quick, if you have slightly different calculator, different version or model of this calculator, and it's not giving you this list, then most likely it's going to show you the following. It's going to show you, let me move to the left. It's going to tell you normal CDF, and it will open the parentheses for you. After those parentheses, you will have to enter those 4 numbers. You just need to remember in which order to enter them on your calculator, but it's the same order. The lower boundary, comma, upper boundary, comma, the mean, and then standard deviation, all separated by commas, and then you close the parentheses, and then you press enter. And it says that the area in between those values on the normal curve, which is the same as probability, is 0.6563, right? So it's slightly different from what we found. So because, well, it happened because we remember how we rounded the z-scores, so we had some rounding involved, and that's why our answer is not quite the same is on the calculator, but it's very, very close. The only difference is starting with 10 thousandths, right? So that's good enough. The first 3 digits after the decimal point are the same, 656. Okay, so let's write this down so that you have steps from the calculator. So on the calculator, you will be using normal CDF function, and you will be entering the following values. So lower boundary is 80, upper is 110, mu, which is the mean, is 100, and then sigma is 15. So these are your calculator steps, and we're gonna try it again for a different example. Let's check our answer for question A. So let's try it. Again, I'm pressing second, then vars to open distribution. So here, vars, and go down to number 2. So normal CDF. I'm pressing enter. Let's see what numbers we should enter now. Well, we need to enter lower and upper boundaries for the region that we highlighted, for the region for which we need to find the area. Now, as I look at this region, I can see that its upper boundary is 112. So I'm going to enter 112 over here. But what about the lower boundary? Well, keep in mind that even though it looks like, and on my picture, that's exactly how it looks, but keep in mind that even though on my picture it looks like the normal curve hits the horizontal axis, in reality, it never does that. So normal curve stays always above the horizontal axis. It's getting very, very close to it, so majority of the area, like almost 100% of the area, is all over here. But there's some insignificant amount of area that stays on the normal curve, going forever to the left and forever to the right, or infinitely far. That means that this region, technically, it's not even bounded on the left-hand side. So there is no end to this region on the left-hand side. But as I just said, the area, as soon as we go outside of the 3 standard deviations, the area and the normal curve becomes very small and insignificant. So that means that in the cases where your region is only bounded on one side, you want to create your own number from the other side. So in our case, it's left-hand side. And you need to take, in this case, some very small number. So to be safe, kind of go as very far from where you are, and further you go, safer you are. But the difference is not going to be noticeable that much. So what I usually do, I enter, if I have to create a boundary on the left hand side, the lower boundary, I usually use negative 99999, like 5 nines with a negative sign. So it's negative 99,999. That's something very far from where I am, and that's the number that's, you know, pretty safe to use. So that's what I'm going to enter here, and the rest is the same, right? That's the same mean, same standard deviation. So let's calculate it. Again, if your calculator did not give you that list, then you would enter those numbers by hand, separated by commas, in that specific order. Don't forget that negative sign is this button, not this one with this is subtraction, but down here. Otherwise, calculator will give you an error message. Okay, then I'm press enter, and it says 0.7881. Okay, yeah, that's what we got as well, 0.7881. Remember, we got it by hand. So let's write down quickly the calculator steps. So normal CDF, and we used lower negative 99999, upper. So lower is always on the left, upper is always on the right, 112. Mean and standard deviations are the same, 115. Okay, let's check our answer for part C. So that's second, VARS, normal CDF. Now I have to change here, right? I have to change things around. What can I say about this region? What is the lower boundary? What is the upper boundary? So lower is always on the left. So if I look at this region, what's the left-hand side? The left-hand side is right here. It's at 130. So I'm going to put 130 for the lower. Now, how about the upper? Well, with the upper boundary, we have same story as before. There's no upper boundary. So we just have to take number that's very large. And again, I will use 5 nines. It's very far from 130, so that's safe to use, considering that I only round my answers to 4 decimal places. So 999 and yeah, 5 nines. Mean and standard deviation stay the same. So I press enter twice and I get the answer. Now notice that when you do it on the calculator, you don't have to do any extra steps. You don't have to subtract anything. You don't have to subtract area from 1, or you don't have to subtract 2 areas, how we did here when we did by hand. That's all happens when you do it by hand with the table. Using calculator, you get the final answer right away. So 0.0228, and that's exactly what we got. So for the record, I will write down the steps. This time I'm going to write them down as if I didn't have that menu and I had different calculator, different model of TI calculator. So then I would enter this. So normal CDF with the parentheses open would be given to me by the calculator, but then I will enter the following numbers: 130, that's the lower boundary, 99999, that's the upper boundary that I chose, and 115 right here. So lower, upper, mean, standard deviation. Okay, so, and then the last question that we're going to do here is the following. We'll just use calculator for that to do it quicker. What is the percentile of a person's IQ of 120? Let me make some notes on the normal curve, and then we'll refresh what the percentile is. 100 is here, 120, let's say somewhere over here to the right. Now, percentile. Let me remind you that percentile represent the percentage of observations that are less than or equal to the one you're looking at. So in other words, we need to find what proportion of observations for this distribution are equal to or less than or equal to 120. Remember, so up to this point we only had to find probabilities, but remember, probability is the same as proportion. And that means that everything ties together. So area and the normal curve is the same as proportion, and it's the same as the probability. So even though this question sounds different, it kind of narrows down to the same thing. We have to find area to the left. Why is it to the left? Because once again, percentile is proportion of observations that are less than or equal to. So I need to find area to the left because of that. And that area, this time I'm going to interpret as proportion. So this area is the same as proportion. And once I find that proportion, then I will rephrase it in terms of percentile. Well, using calculator, we find this area by pressing second, vars, then go down to line number 2, normal CDF. Now I have to describe my region. What is the left boundary? Lower boundary, right? The lower boundary is the one on the left. Well, I don't really have it, so I'm going to create it myself. Very small number, so negative 9999. What is the upper boundary? The upper boundary I do have, right? It's 120, the one that's on the right, 120. Mean and the standard deviation stay the same, since I'm doing still same example. So I'm gonna press enter 2 times and I'll get the number 0.9088. 0.9088. Okay, so that's proportion. Proportion of all observations that lie below 120 or less than or equal to 120. In other words, percent of people that that have scores that are less than or 120 points is, so what? How do I interpret or convert it to percent? I just moved decimal point 2 places to the right. It's approximately 91, right? So it's 91%. 91% of people would score 120 points or less. And that means that 120, that score, that specific score, is called 91st percentile. 91st percentile. So percentile, it's the measure of position, so it always corresponds to a specific data value. So that's how you answer your question, answer this question about the percentile.